So we are a Berlin-based startup, deep tech. This means we are really having a deep tech mission to fulfill. And our mission to fulfill is to be one of the manufacturer of the so-called next generation of batteries. So what's called next generation? These are batteries that are actually not on the market, not completely developed. So we are one of them. And our big USP is that we are using sulfur as the main battery to make our product. So for battery, you always need an anode and a cathode. So two materials you have to pair together. And for the cathode side, we are using sulfur, and for the anode side, we are using lithium. That's our biggest difference. I think the specific part of the battery manufacturing is it's a combination of a lot of different industries. So it starts with the mining of the raw material, where we are not involved. Then it's more, let's say, process industry, more the chemical part of the assembly. Then we have a traditional assembly. And then we have a so-called formation part. This is when the batteries, after the mechanical assembly, are first time charged. And this is very decisive in the lifetime of a battery. And so we have a lot of data what are generated. So we have data generated from the machines, like in every other industry, but also from the very first, let's say, life cycle, the battery starts to generate data. And so our big chance what we have, and why I think the data are so important for us, because our product is generating from the very, very first minute already data about the actual behavior, and we must use this data to generate a prediction how good is the quality of the battery. Because we have so many different process steps, we have so many different materials, and we cannot wait 50 days until the manufacturing and the aging steps are done. So we must have an early indication, a predictive model, to see if our manufacturing is working or if we have some, let's say, problems to solve. Okay, that's the point of a battery. That's also quite special. So there are basically two KPIs what are important for the market when it comes to battery. One is how much energy you can store, and the other one is the cycle life. How often you can charge and discharge your battery. And a very typical specification is, for example, 1,000 cycles. So assume I charge a battery and I discharge, it will take 1 hour. So, and if I have to wait 1,000 hours, then I have to wait quite a long time to prove if the life cycle of the cell is basically in spec or can be achieved or not. So what we are using the first 15 cycles, because this is something like, it's called formation cycles. This is where the electrical chemical system in the battery is created. So it's like you have to look at it like a creature. So it starts to get alive, and this first responses of the battery to the first charging gives you a good indication of a later performance of a long time. And this is what we have done in our project here, that we look at the first 15 cycles mainly, what is happening and what are the responses of the battery system, and then we can predict with a very high percentage if the cell can reach, let's say, the designated cycle life or not. So we can reduce the number of physical cycle channels what we are using, and finally we can save a lot of time. If we can say in 1 day what we usually have to wait 40 days, that's obvious. That's a business case what I can do on a whiteboard and don't need an Excel.